Hey, ciao Milano. Really happy to be here as a person from the foundation. So yeah, today we're gonna talk about the modular L2 stack and specifically about some of the most exciting things that are happening in Arbitrum. So 2 words about myself. I'm Lorenzo, as I said. Currently working as a head of technology at Arbitrum. My background is in tech. I spent like 15 years plus in different industries. As you can see, I'm not really young, unfortunately for me. Worked in Consensus for like 3 years as a tech lead there. After that, a bit more DeFi, NFTs in the trenches. And then I joined a Web3 accelerator called Outlier Ventures. Actually, last year I was here in a panel in behalf of OV. And then, yeah, in January, I joined the foundation, and now I'm working in DevRel, data, technical advancement. And yeah, I'm very keen also to talk with people that are here today building in the ecosystem. I already had great chats. And yeah, it's really good to see in Italy such energies. If you want to talk with me, you can reach out to Twitter, you can scan their QR code, etc. Without other further ado. So, oopsie, interesting format. Anyway, so how we work and how we win as a L2s while Ethereum matures. Definitely it's not by competing with Ethereum. I think we had a lot of drama there. That's not the plan. And also we can't keep just copy and paste and create new L2s one after the other that they don't have too much differences between them. So what we believe is really about like being innovative, interoperable, and leverages the characteristic of Ethereum and basically anchor the security to the layer 1. Arbitrum is not just a layer 2. It's not only tech, despite it's heavily tech related. So Arbitrum is for sure great and scalable tech. It brings you like fast and cheap transactions, for sure. Like block time is a great concept, 250 milliseconds on Arbitrum 1, but if you move in other setups, you can even reach 100 milliseconds, and we're working to even lowering the block time. Another aspect is the liquidity. So Arbitrum is the home of DeFi and has been like great in that area and still is one of the most active in the DeFi space. In fact, is the most liquid L2s, and you can like have 14 billion of liquidity. Specifically, I think it's around 6 billion on stablecoin. Also, it's not just about Arbitrum itself, it's about the ecosystem, and the fact that we're here talking today is really that point. So you're gonna end up to reach and work with an existing ecosystem that developed over the years. And then, yeah, decentralized, we really care about that. We're gonna talk again about this later, but we are pretty close to have a stage 2 level, and we worked this year to improve our status there. So we are really happy about that aspect to be decentralized, in fact. And finally, like the flexibility, like while you can deploy in Arbitrum 1 or in Arbitrum Nova, you're also free to deploy your own chain, which is partially of why we're here today talking about the modular stack. One more news, my titles are old school, unfortunately. I'm really sad about that, but nothing too bad. What happened a few weeks ago is the fact that we added to the contributor of the Arbitrum ecosystem 2 other players, Nethermind and Aragon. They will develop the execution client and all the bits that are useful to run a rollup. And so that's now towards alt clients directly available to the entire ecosystem. It's a quite large project. We are super happy to support that. The great news is that depending on the tech stack, in case of Nethermind, it's really about the performance you will get through the execution clients, rather than in case of Aragon, you will get huge saving in terms of archive nodes. Nevertheless, all the tools are available to basically the builders, depending on their use cases. What we are envisioning is that people will use actually all those clients in different setup, which is really great for the reliance of the entire ecosystem and tech and infra. So, moving back to what we were saying at the beginning, how Arbitrum is innovative. I think we have a lot of great examples. Number one is really the ETHMilan Plus. At the beginning of this year, in September, we started to launch the first production-ready stylus version, and we ended up to basically double down on the ETHM. And in fact, we added another virtual machine. And so now we have this setup where we can have both ETHM and ETHM Plus. Sorry, and the WASP virtual machine. How it works, really in a nutshell, we have basically actually two virtual machines running in parallel. So rather than the other L2s, they have exclusively the Ethereum virtual machine. In the case of Arbitrum, you get the Ethereum virtual machine together with WASMer that basically allow you to run any smart contracts that can be written in a language that compiles to WASP. So, why we ended up to do that? And there are a few reasons. Like, first of all, when Ethereum came up a few years back, it ended up to target the developer experience rather than performances. So they ended up with these 256-bit words as a base layer, which was great for all the cryptographic primitives, but not exactly performant, because in fact, today CPUs works in either 32 or 64 bits. So they were conscious about that, but the result is basically that the virtual machine is lower, because the memory registry got bigger, but also they couldn't end up to have like just-in-time compiler through the virtual machine. So there were trade-offs through WASMer and Stylus in general. We are really improving the performances, giving the chance to the smart contract developers to have options. So why Stylus matters? Despite the title being super small, the thing is it really shines when it comes to CPU and memory-heavy tasks. It's important to keep in mind. Now, every tool shines in a different type of setup, and Stylus shine in this one. So if you can compile to a WASMer, such as, for example, with Rust, that's great. You can basically leverage WebAssembly to get your smart contract running through that, which means you can now have an ETHMilan Plus environment where you can move between the two virtual machines, depending on the use case. And also you get some nice features from the security perspective. For example, by default, you have re-entrancy guard directly in the SDK. And finally is multi-language. Not only we support two virtual machines, but also we allows you to pick different languages. In truth, right now, the most mature SDK is Rust, but in paper, we actually can run smart contract even in C, C++, and Zig. Ultimately, we did some experiments. So it's a quite flexible foundation layer that we can leverage also down the path. And then last but not least is this co-equivalent. I have another slide around this concept, but you can basically call between the smart contracts written in Solidity calling a Stylus and vice versa. Very high level, this is an example of a Stylus contract. And with the Stylus SDK 09, we added a couple of new features, pretty cool. One is the constructor. I know it makes a bit like laughing that we didn't have a constructor, but there were like technical reasons for that. Now this has been solved. So you can initialize in the same transaction the entire contract. And second, we added also a better inheritance primitive. So now this is available in the SDK 09, so pretty cool. And the other element of Stylus is this interoperability that you can have between contracts. So on the left side, you have Solidity, and highlighted the last line is calling a smart contract written in Stylus, specifically in Rust, that is quite computer heavy. So this nested loop, it's a classic bad things to do in Solidity, which is actually quite fine to do in Rust. And the reason is because when it comes down to CPU and memory, Rust really shine. So you can have that directly in Solidity, that you leverage a library, for example, written in Stylus. And that's pretty cool. I can have hashes, like there is now this new library from OpenZeppelin called the Poseidon hash, pretty cool. But here in this example, there is a workshop where we are creating SVGs directly on chain, quite complex, and you can do that in Stylus and then call it in, from Solidity. And vice versa. So you can also, from Stylus, call Solidity when it matters. Okay, but this is in theory, but not only in theory. Actually, people are already using Stylus in production. There are different projects doing that. More are also coming. We have starting to have example, for example, of Uniswap hooks written in Stylus with pretty complex business logic implemented there. We have a superposition with a protocol. Actually, they are also building another one in Stylus, which is also quite interesting. And then Renegade ended up with this concept of dark pools directly written in Stylus. And finally, the Stylus on the Fireblock with this dynamic MPC. More to come, a lot we're expecting also in gaming and other concepts. So you can see that basically when memory and CPU matters, Stylus is a great option. Okay, so that was one innovation that is happening. And the other one is maybe less developer-oriented in a way, but I'm very curious. How many knows about Time Boost today? Can you raise your hand? Okay, not many actually. So it's like 4 or 5 people, which is great. So I'm happy to break the news. So what the heck is Time Boost? To understand Time Boost, we need to do a step back and understand an acronym that is MEV. So what does it mean is this maximum extractable value. And it's really a definition about what can happen on chain when people can reorder the transaction to basically have a gain. And so they can either exclude, changing the order, or even drop the entire transaction. When this happens, your transaction that you are maybe try to swap your token for one for the others, well, you ended up with a different result. The different result goes in advantage for those searchers that they figured out how to take advantage of that. Why this matter for Time Boost? Well, first of all, yeah, maybe before jumping there, is this concept of how you can lose money as a user. There are different ways to do that. Like someone can front run you. So basically they see you are buying something big enough, they can jump in front of you and buy before you do. They move the price, so your new price is not as good as it was one transaction ago. Or yeah, well, basically one iteration before yours. That's one way. The other way, even worse, it's a sandwich attack. Not only I will change what happens before you, but also what happens after you. So you will end up like heavily screwed. That's the truth, what happens in the sandwich attack. The last one is considered the most ethical one. It's called like backrunning, which is what I'm gonna do just after you did something. Why is considered like nicer is because you're not gonna lose money, you, on your transaction, but I will take advantage of the new situation just after you did it. So moving back to the original question, why this matter is because actually MEV was quite important when Arbitrum ended up to be designed and the architects ended up to pick a solution. And this solution is called like first come, first serve, and it's embedded in the sequencer of Arbitrum itself. So we pick that solution because it has great benefits. What does it mean first come, first serve is that as soon as you get a transaction, that's the order. No one can shuffle that transactions back or try to do something. So the sequencer is fair with everyone, doesn't try to take an advantage. It's great for block time because we don't need to shuffle those transactions in any specific order, so we don't lose a CPU or memories to figure it out how to do it. And it's one of the reasons why we can push those boundaries to 100 milliseconds block time or even 50 millisecond block time. The other aspect is if everyone comes first in, first out, well, then all the discussion we were doing earlier about changing the order to screw the user, they are not up to the game. Just to make a bit of like example, like what happens on Solana or Ethereum layer 1 is that you can actually change that transaction order. So in Ethereum, we ended up to build an entire infrastructure to avoid that or to protect the user or having an order book that goes in a specific direction. In Solana, they didn't have, and that's why they ended up to have so many meme coins, because actually the winner were the people doing the infra deals and basically front run and sandwich any transaction. So in Arbitrum, you really have a fair user experience. But because of this first come, first serve, also we got some cons. And first cons is the fact that the infra is actually stressed a lot because bots. So what bots are doing in Arbitrum is not try to front run or sandwich attack you. They actually try to get advantage as soon as you did your trade. And how they do that is by keeping calling our infra to be the first one to have the latest price update, actually the latest block. And so as soon as they get that, they're happy and they can execute the transaction. What they do, they spam a lot. And so that's a heavy cost for the ecosystem. Also, once they get that, the MIF that they can extract from backrunning your transaction goes entirely to the searchers. So no benefit for the ecosystem. And so here we go on why we ended up to build Time Boost. So Time Boost brings quite a few of novelty. First of all, it's an auction. So it doesn't matter anymore how fast you are to get that information. It matters how, if your price is better than someone else. And particularly the system we designed is with this second price auction. You offer the best price you can, but actually you will pay the second price among the two top winners. The other thing is that the MIV allow only backrunning. You can change the transaction. You can't change the transaction order. You can just put your transaction as a first one. And third, the ecosystem is the one that get the benefits, and we will go there. But basically, something pretty cool is happening behind the scene as we speak. And finally, yeah, it's cheaper to run the infrastructure, which is not maybe a direct input today, but the direct benefit today, but it's very good for the long term of the entire Arbitrum ecosystem. Very high level, I don't want to go too much into detail here, but there is an auction, and so on the left side we have the searchers sending a sealed bid to this autonomous auctioneer, which is actually an off-chain element. And as soon as basically we figure it out in a given time who are the top two bids, this is sent to the auction contract. And then the sequencer, every cycle, will resolve the auction and pick the winner. The winner get the nice express line, that is the one in blue. And basically, their transaction is not delayed. Everyone else got 200 milliseconds delay. Who won the bid is the first one in the lane, which is pretty cool feature because then I can decide what to do with the result of the previous block. Really, really quickly, like if you are a developer, if you are a fan, if you are a researcher in the room, that's basically someone that could actually be a participant of those auctions. And how it works is TypeScript request, there is an endpoint that you can call, there is an SDK you can use to send your best price for the next transaction to be included. Similarly, if you win, then now you are the express lane controller. So you are allowed to send that transaction to the sequencer for the immediate next block. And that transaction can do whatever you think is best for you and get the benefits out of it. Okay, but so who is using this time boost today? It's pretty cool, actually. Entropy did quite a bit of work to track this. We are also working in other dashboards that they go even deeper than that. But what we can see already today is that people are using this characteristic, and you can see that there are clearly winner and second place, etc., etc. And it's also quite healthy. I mean, it's true, 65% goes to Selene Capital, but nevertheless, like that is the market evolving, and it's the first version of Time Boost. But we can see that there is a kind of product market fit. People are using this, and it's not just 2 or 3 players. Actually, we have a healthy ecosystem of different people try to use this new primitive. And so for the ecosystem, what does it mean? Like, does it work in terms of like benefits? Well, actually, it worked quite well. Like since the genesis, we are roughly, and this number is going up. I think it's almost 1,700,000 now. So in 2 months, this is quite interesting result. Like we're talking about 10 million annualized. So it's a great revenue for the entire ecosystem because this goes directly to the DAO. 8% goes to the DAO, 2% goes to the Arbitrum Developer Guild. So that's, oopsie, sorry, tried to kill myself. And the other element is to put in perspective the impact of Time Boost in the entire ecosystem revenue. So after 2 months, Time Boost is counting for 50% of the fees of the entire ecosystem. I think that is a remarkable achievement for Time Boost. So really, really happy to see what's going on the ecosystem side. Really innovation happening as we speak. Okay, moving on the third item, which is Arbitrum chains. As you know, in Arbitrum, you can deploy your own chain. And you can do that through an Orbit SDK, which include Nitro, that is our today execution client. And you can do that as a RAS, with a RAS, or independently. You can also have different type of data availability, either directly as a rollup in Ethereum or with any trust with different trade-offs, or even other solution of data availability. And finally, if you pick the Arbitrum chain, you can actually customize quite a bit of how you do your block, how you build your block. You can have a custom gas token, you can have precompiles, you can customize your block times. There's quite a bit of liberty there. Other goodies, well, what we were discussing earlier in Stylus, it is included in Nitro Codebase, which means you get the exactly same feature of Arbitrum 1 in your own chain. It's extensible, as we said, but also you get all the feature of the security updates coming from Nitro directly in your chain. It's quite secure because you're not customizing and modifying your SDK, taking a lot of risks, but you are starting from a very mature tech and you're adding your changes. Of course, it's not simple. If you decide to change your precompiles and other things, you need to go through security audit and all the work that needs to be put to have a secure chain, but the base is really great. Account abstraction, again, is implemented now since ARB 40. We got also the AP 7702 directly included. The ERC 4337 was there since a while, but you are really getting all the goodies of the layer 2 and plus whatever you wanted to add. Gas price reliability is another aspect. Your chain will be siloed in your ecosystem, so you do not have this swing of pricing that can happen in Arbitrum 1 or in other chains where you are sharing your block space. So you could decide to have it in a permissioned way or permissionless. That's up to you, but you can clearly get benefits of price reliability. And yeah, I already just mentioned that. So you can have your contracts or allow everyone to deploy. That's your choice. Okay, moving on. That's one of the things that I like the most about Orbit chains is the fact that you can deploy them in a variety of setups. You can be a layer 2 and settle on Ethereum, or you can have a layer 3 settling in Arbitrum 1, or even a layer 1 if you really want to be a layer 1 leveraging our stuff. It's a quite flexible technology, modular in a way, allowing you to pick your trade-offs. Licensing, how it works. If you are on L3, it's a no-brain. You click, literally, you go to a RAS platform, you deploy your Arbitrum chain, and you are up and running. There is nothing to do. You are settling on Arbitrum 1, no fees are owed, and everything works out of the box. If you pick a different type of setup, then there are some elements to take in account. First of all, it's a BSL license, so it's open source, but at the same time allows you to run the nodes as you prefer, like you have plenty of liberty in that sense. What we want to make sure is that the ecosystem have benefits by you using the tech stack we developed when you are, for example, settling in other spaces. So in that case, we use what is called Arbitrum Expansion Program that basically allow you to deploy the chain as it fits, but then in that case, you pay 10% of your net revenues fees to the DAO. So it's slightly different, but still, you can do it as long as you fulfill those requirements. So we do believe that is a quite flexible solution, pretty clear in terms of how it works, and yeah, people are doing this already. So just to have a quick explanation of what you can customize. So a lot of those customization goes through what is called precompiles. What are precompiles is basically smart contracts that you are putting in your chain, but rather than be executed by the EVM, can be executed natively by the execution client. So the performances are way higher, but you can register them in this precompile.go, and now they are accessible to everyone that is using your chain. And then you create those ABIs. So the ABI, for who is not a developer, is basically the interface that you need to provide for an external program to call yours. And so as we do for smart contract that we need the ABIs, the same we do for those precompiles. That's the same concept. And then once you have your precompile, you get it compiled through WASP, and then you're going to add it as a WASP module on the chain. That's now part of your deployment. And finally, yeah, just deploy it, and you can access it, and you have a precompile that can bring, for example, your new hashing algorithm or your way of providing a calculation that are pretty heavy and you couldn't afford to do through a smart contract, and things like that. So, be or not to be an Arbitrum chain is a very good question. I don't think there is a straight answer if you should do it or not. It really depends. But I think there is some element that you can take in account. So on the left hand, you have the situation when you pick Arbitrum 1. And in that case, you get the ecosystem, you can tap in the liquidity, and you get the fast, secure, and composable element of the DeFi primitive, so you can combine yours with other smart contract already deployed. And finally, like, you don't need to have any IT infrastructure or knowledge of the IT infrastructure, which is, like, in my opinion, in the startups that is try to get product market fit. It's a pretty cool feature. On the other hand of the spectrum, it's a completely different experience. Like, you can tailor your block space, literally how the block are built are under your control. So you have a great responsibility in terms of how you do that, but you can do it. You have this dedicated throughput, so the performance is isolated from the rest of the ecosystem. And finally, oopsie, I left a Laura Ipsum Dollar. Apologies about that. You got the custom gas token that you can have, and of course, from a token design perspective, that it's a pretty cool feature. But yeah, it comes with responsibility as well. Okay, so if you wanna be an Arbitrum chain and you wanted to deploy, you have two options today. The simplest is go through a RAS, and there are plenty of them. Here I listed the ones that currently we are working with, and we are also officially supporting them and help them to run those chains. Or you can run as independent. It's definitely harder to do that, so be careful to deciding if you really are ready, but you can do it. Like, the product, like, everything is open source. Okay, but is this theoretic? Is this like a new tech? Well, it's a tech that is evolving, but it's a tech that is already used. And we already mentioned it, that there are chains such as like Ape Chain or Proof of Play on the gaming and Gravity and other type of chains. But a big one that is now joining the ecosystem is Converge, that is built by Securitize and Athena, that they are deploying and building their own Orbit chain. It was a long discussion with them, but we are really, really excited of what comes next from them. And you can see that this is a protocol that scaled in a layer 1, found the product market fit, and now they are scaling, becoming a chain, which is a concept that I like from a product perspective. So interoperable, I need to go a bit faster. So we have this roadmap about the universal intent engine. This has been a long discussion about what happens in this multi-chain world. It's fantastic to have that diversity, but it brings different type of challenges. And so we ended up with fragmented liquidity, isolated networks, a kind of an assets nightmare if you are in your wallet and you see 5 type of USDC, 6 type of Ethereum, like very, very painful. And like when you move between chains, like also slow transfer. It's a really challenging aspect from a UI perspective. And the good news is we have a solution and we have an approach through Arbitrum tech. So the idea is to have something that is trustless, oh my gosh, cheap and fast. What does it mean really in terms of tech involved? There is like 4 elements here that are really important. Standardize, which is really hard work. Like I'm doing that daily, discussing with different teams, different people, to make it sure that we come up with a standard of running the intent framework. Because otherwise we're moving from one problem to the other. So there is a very important effort to synchronize the actor. We need to have a broadcast standard as well. So make it sure that when an intent is ready, so when a person tells me, hey, I want to move my asset or I want to buy in that chain, there is a place where this can happen and there is a unified view of this. Has to be fast, and here always people want things fast, but in order to achieve that, there are trade-offs, and we are figuring out the right way to do it. And finally, the feed of the intent needs to be available to all the solvers. So having market dynamics and be neutral in that aspect is so important, because we know that market will optimize by itself if there is enough visibility. Otherwise, you start to have different pools. Okay, last item is leveraging Ethereum security. I want to also leave some time for a question if you have. So Bold is something we launched, I think, in February, and it brought a nice slice in this pie. I don't know how many knows what this pie mean. 1, 2, 3, 4, yeah, very few people, 5 maybe. Okay, so this is L2Bit that came up with a system to really grade the quality of the rollups when it comes down to the security trade-offs. It's not about everything, it's about the security trade-offs. And so before Bold, we had this issue on Arbitrum and in all the rollups, to be fair, that is called delay attack. Don't want to go into detail, but basically a malicious actor could, without put the chain safety at risk, it could basically attack the liveness of the chain by postponing the settlement and by keep challenging the chain and saying that this withdrawal is wrong. And so by doing that, it was possible to block the roll-up settlement. And because of that reason, we ended up to have a different setup on Arbitrum for a long time, where only whitelisted validator could run the setup. And that was the reason why we ended up to think and figure it out different approaches. So we ended up with this concept called bounded liquidity delay, and we found that this was a bit hard, so we came up with Bold, because we love acronyms. And so what Bold give us is a new permissionless dispute system. So rather than having whitelisted validators, now everyone can dispute a challenge, because the disputes are on Ethereum. So you have one single place where you can go and dispute. And you have also a fixed challenge time, which is very important, because we were saying, like, in the delay attack, I can just like block you by keep challenging. And if I challenge one after the other in series, then I block the chain. So with this approach, we found a way to basically prevent that. And finally, that basically what brings us towards the stage 2. Finally, what happens before and after is the big unlock is that before we were sequential, and now a single trusted, honest party can parallelizing solve all the challenge in one single challenge time. So it doesn't matter how many challenges you do, I can solve all of them in one cycle. And that's the unlock, basically. And like, let's take it as a black box, because I'm not a cryptographer to go in all the details, but that is the unlock we ended up with. So the result is that we moved from left to right. So we had the one yellow slide on the state validation, because it was not permissionless validate the rollup. And so now with both is permissionless. And so now we are one slice away to be fully stage 2. Watch this board, because in 30 days, many people will move back to stage 0, rather than Arbitrum will stay in stage 1, because we are fully compliant with all the aspects in terms of security and trade-offs when it comes down to rollups. Finally, wrapping up and open the floor. So what we did today is really building the future one block at a time. I introduced Stylus, Time Boost, and Arbitrum chains. All of them cover basically the innovation, the interoperability, and everything is anchored on the layer 1 security, in this case, of course, Ethereum. So this is it. If you are building, please scan this QR code. We are putting together a newsletter that will actually target builders and developers in the next few weeks. So we are really keen to talk with you when you are building. And so, yeah, please scan it. That's all on my side. And thank you so much for the time. If you want to talk with me, I am around. And again, thank you so much for having.